Hi everyone, this is Sadish Kumar from Kognad College of Engineering and Technology, Totium Trichy. Now we are going to discuss about agriculture drainage, which is fifth unit of our irrigation and drainage engineering subject. It covers some topics: agriculture drainage, drainage coefficient, principles of flow through soils, Darcy's law, infiltration theory, surface drainage system, subsurface drainage, design of subsurface drainage, pipe materials, mold drains, drainage wells, leaching requirements, irrigation and drainage water quality, recycling of drainage water for irrigation. Agriculture drainage drainage system is a system by which water is drained on or in the soil to enhance the agriculture production of crops. It may involve any combination of stormwater control, soil erosion control, and water table control. The process and practices used to remove excess water from the soil surface and from the soil profile, that is called agriculture drainage. The main objective of agriculture drainage is to collect and remove the wastewater in the agriculture field. Then benefits of agriculture drainage system. Drainage provides a better environment for the plant growth, increased microbial decomposition. Drainage improves the physical properties of the soil. Drainage maintains the proper soil temperature. Drainage promotes increased leaching, less time for labor requirement, better root system, reduces soil erosion, removes toxic substances. Structure of the drainage is means device which drain the water off and or away from the road. Drainage structures include such as water bars, ditches, French drains and culverts, under drains. These are the structures of the drainage. Then drainage limitation. Soil with drainage limitation include wetland soil, hydric soil, and poorly drained soils. All these soils have a common characteristics. They have aquatic soil moisture regime. The surface methods of agriculture drainage: one is surface drainage, another one is subsurface drainage. The regular surface drainage system which start functioning as soon as there is an excess rainfall or irrigation applied. The beaded system used in flat lands for crops other than rice. If you are coming for subsurface drainage system like field drain systems, subsurface field drainage system can also be differentiated in regular system and checked systems. When the drain discharge takes place entirely by gravity, both of subsurface systems have much in the common, except that the checked systems have control gates that can be opened and closed according to the need. They can save much irrigation water. Checked drainage system also reduces the discharge through main drainage system, thereby reducing the construction cost. Then applications. Surface drainage system are usually applied in relatively flat lands that have soils with a low or medium infiltration capacity, or in lands with high intensity rainfalls that exceed the normal infiltration capacity, so that frequent waterlogging occurs on the soil surface. Subsurface drainage system are used when the drainage problems is mainly that of shallow water tables. When both surface and subsurface waterlogging occurs, a combined surface subsurface drainage system is required. When land needs a subsurface drainage system but saline groundwater is present at a greater depth, it is better to employ a shallow, closely spaced system of pipes or ditches instead of deep, widely used system. The reason is that the deeper system produces a more salty effluent than the shallow system. Environmental criteria may then prohibit the use of the deeper systems. Then drainage coefficient. The drainage coefficient is the design capacity of the drainage system and is typically expressed as a depth of water removed in 24 hours. A drainage coefficient should be chosen that will economically remove excess water from the top part of the root zone within 24 to 48 hours. So these are the some of the coefficients for different topographic soils. So principles of flow through soils. The seepage through soil is defined as the flow through fluid through pores of the soil under the pressure or gradient. Two major forces move liquid water through the soil pores. Gravity one, then when soil is saturation. Then Darcy's law. Darcy's law states that at which the fluid moves through the permeable medium, like groundwater movement through an aquifer, is directly related to the difference between the vertical elevation at a different points of the medium and directly related to the distance between those points in the medium. The Darcy's law Q is equal to that is unit discharge divided by area, that is called Darcy's law. Then infiltration theory. Infiltration is the process by which the groundwater enters into the soil. It commonly used in both hydrological and soil sciences. The infiltration capacity is defined as the maximum rate of infiltration factors infiltration. The infiltration is caused by gravity, capillary forces, absorption, osmosis. The measurement of infiltration includes head-based method, ring infiltrometer method, double ring infiltrometer, single ring disc infiltrometer, tension disc infiltrometer, mini disc infiltrometer, flux-based method, rainfall simulator. These are methods to measure the infiltration rate. Then surface drainage system. It is mostly used as ditches and drains. In these ditches it has a shallow surface drain and medium sized. Up to 0.3 it is shallow, 1.3 to 1 meter depth it is called medium sized drainage system. The surface drainage system mostly it is like a canals are act as a drainage too. In some cases drainages are separately provided for drain of the water. Then subsurface drainage, a preferred contact such as pipe, tubing or tile installed beneath the ground to interpret, collect and convey the excess groundwater to a suitable stable outlet. The purpose and benefits of surface drainage. Subsurface drainage is a removal of excess water from the root zone. It is accomplished by a deep open drains or buried pipe drains. The subsurface drainage is an important conversion practice. Poorly drained lands are usually topographically situated so that when drains they may have be formed with little or no erosion hazard. So this kind of subsurface drainage system will helps for some content. The aeration of soil for maximum development of the plant root and desirable soil microorganism, increased length of growing seasons and decreased possibility of adversely affecting the soil tilth. Then improved soil water condition, remove the toxic substances, greater storage capacity for water. So these kind of benefits are there. Apart from this, adding productive land without extending the farm boundaries, increasing the yield and quality of the crops, permitting good soil management, ensuring that crops may be planted and harvested at optimum dates, eliminating inefficient machine operation caused by small wet areas in the fields. Then purpose and benefits of subsurface drainage system. Aeration of soil for maximum development, increase the length of growing season, decrease the possibility of adversely effect of tilth, improvement of soil water condition in relation to operation of tillage, removal of toxic substances, greater storage capacity for water resulting in less runoff. Then design of pipe drainage system contains layout of drainage system. The layout is to be covered as shown in our figure. It is mostly covered all the areas. It may be tree system or regular system. A, B, C drawings are there. Through this system we can lay our pipe system for drain of the water. Then location and alignment of drains. It is to be located near to our surface so that we can extract the water in our ground level. So A and B type of drains are to be provided to drain off the water. The spacing is to be decided based on the capacity of the infiltration capacity of the soil and the pipe size. Then these are some other diagrams for our drainage wells, drainages for drain of the excess water from the soil medium. So this is also another view of that. This kind of options are available. We can adapt which method is suitable for our location. We can adapt it. Then outlets. This kind of outlets must be provided for safe removing the water from the collector, so that we can easily extract the water. This kind of pipes are comes out, then we will drain off the water from this location. This kind of drains also be provided in the subsurface system to collect the water. These are called as pipe connection for removing this water. So this step by step will be and will maintain an radius for extracting the entire water from the subsoil. Then this kind also be utilized for avoiding the clogging effect. This is called as manholes like structure is to be provided to avoid the silt entry into the pipeline, so that periodically this holes will be cleaned. Then this is also another view of our regulators of flow. So we can regulate the flow with some locks is there. With the help of that plug, we can regulate the water to enter into the outlets. Then this is also another one option for that, collecting the water. This kind of U shape is called as siphon type. We can collect the water through that medium. We cannot convey the silt particles. This silt particle is to be trapped at the tank itself. Then pipe materials for mold drains. Mold drains are unlined tunnels in a clay subsoil formed by a mold plow. A mold plow is composed of a shank legged to a cylindrical belt followed by a cylindrical expander. The expander strengthens the channel by compacting the wall. The process of pulling the mold plow results in soil cracks. The effectiveness of mold drains depends on the amount of soil cracks that help water movement toward the mold hole. Types of mold plows is trailed mold plows, semi-tractored and fully tractored gravel mold plows. Then tractor plows will having required of capacity 60 to 80 kilowatts. Then speed mold plows require 2 to 4 km per hour. Then soil stability of mold drains having is implemented in clay soil with an percentage of 30 to 35. The next one is mold drains over the collector pipe system. The mold drains is provided like that. Below the surface of the soil, it is approximately 400 to 600 mm depth. With the help of tractor, we can plow it. With the help of plowing, we can lay the pipelines. With that, we can drain off the water. Then drainage wells. Drainage is employed in the reclamation of wetlands, in the prevention of erosion and confinement irrigation of the agriculture and of arid regions. A dry well is a well that is used to transmit the surface water, groundwater, surface water and ground underground, and is deeper than its width at the surface. Most dry wells are 30 to 70 feet deep and 3 feet wide at the surface. The sanitary drainage, waste drainage, vent drainage system, then storm drainage system also and utilized. The advantages as increase the crop yield, less year to year crop yield variability, then increase of soil aeration, improves the soil structure. Then disadvantages, excess phosphorus transport, then excess nitrate transport, less groundwater recharge, accelerate soil of organic matter. Then problems of drainage, blockages, broken off displaced joints, fractures, root intrusions, collapsed sections of pipes. These kind of problems are there in our subsurface drainage system. The next topic is leaching. It is defined as the fraction of the irrigation water that must be percolated out of the bottom of the root zone in order to prevent the average soil salinity from the rising above some specific level. That is called leaching. Requirement is equal to depth of water drained out per unit area divided by depth of water applied per unit area. That is called leaching. Then then components of leaching, contract, separation, extraction are the major components of our irrigation system. Then types of leaching, it is cyanide leaching, ammonia leaching, alkaline leaching, acid leaching. These are the major leaching effect which is available in our world. Here it will be a common leaching is utilized for that. Apart from that, water leaching is the only system which is available in our agriculture field. Then advantages and disadvantages of leaching. A leaching chamber is constructed of a lightweight material that can be transported comfortably to trench that has been excavated. When leaching eliminates too much nitrate from the soil, the pH decreases too much and the soil becomes over acidic. So that we have to keep in mind these 2 points for leaching your effect. This kind of problems will be discussed in our classes. Then water quality for irrigation. So salinity required for irrigation as low salinity as less than 0.6, medium salinity is 0.16 to 0.5, high salinity is 0.5 to 1.5, then very high salinity is 1.5 to 3. Then salt index, that salt index is to be identified by total Na minus 25.4 minus total Ca minus Ca in CaCO3 into 4.85. Through that we can find out the salt index. Then sodium absorption ratio, the high concentration of Na plus are undesirable in water because Na plus absorbs onto the soil cations exchange sites, causing soil aggregates to break down, sealing the pores of the soil and making it impossible to water flow. This is about soil absorption ratio formula. Based on the low sodium Na plus less than 10, it is any type of crops grown and water used, and for medium Na plus 10 to 18, for high Na plus 18 to 26, very high more than 26. Then bicarbonate hazard. It is very low, it is less than 1.25, medium 1.25 to 2.5, high value is more than 2.5. Then boron concentration, low is very low is 0.33, very low is 0.3 to 0.67, medium is 0.67 to 1, high is 1 to 1.5, very high is 1.25. Then chloride concentration, it is 4 is excellent water, 4 to 7 moderate good water, 7 to 12 slightly unusable, 12 to 20 and more than 20 is not suitable for irrigation purpose. Then sodium soluble sodium percentage is determined through these equations. Soluble sodium divided by total cation Ca plus Mg plus Na plus concentrations into 100. Then magnesium hazard, magnesium is believed that one of the important qualitative criteria in judging the irrigation water, it is magnesium content in relation to total divertant cations. Then nitrate content, very frequently groundwater contain high amount of nitrate. When such type of irrigation water is applied in soils continuously, various physical properties of soil are affected. So low nitrate is up to 5, less than 5. Then medium nitrate 5 to 30, more than 30 is called as high nitrate. Then lithium is a trace element, may be found in most of the saline groundwater irrigated soils. It has been found that small concentration. Then fluoride is one of the another factor which is followed in the groundwater. Then recycling of drainage water is required for irrigation purpose, as we have to treat the water, then we are going to supply the water for irrigation, or otherwise our irrigation will keep on gets affected, so that we can't cultivate the crops properly. So up to this our topics will be over. Thank you.